Chernobyl. You've probably heard the name. It was the site of the most significant nuclear accident in history. Keep watching to find out what happened and how the accident at Chernobyl fundamentally changed nuclear safety, making today's systems safer, more transparent and more robust. On the 26th of April 1986, Unit 4 of the Chernobyl nuclear power plant, around 110 kilometers north of Kiev, was due for routine maintenance. The plan was to use routine shutdown, when a power plant isn't generating electricity, to run a safety test. Many nuclear power plants use water to keep their systems cool. Pumps are used to circulate that water. Because nuclear fuel continues to give off heat, whether the plant is operating or not, the cooling has to continue even after a reactor has been shut down. The test was meant to check whether the pumps would keep running without power for a short time. It was expected to last between 1 to 2 minutes, but things didn't go to plan. A combination of design flaws created the conditions for a runaway power surge. In most reactors, cooling water turning to steam would slow down the reaction, but at Chernobyl, it did the opposite. As water turned to steam, the nuclear reaction accelerated, creating a feedback loop of more heat and more steam. Operators had also held the reactor at unusually low power levels for a long time. Without knowing this, put it in a highly unstable condition. The reactor needed to be shut down, and the test rescheduled. But operators, under severe pressure to complete the test, forced it to increase power. When they realised there was a problem, operators pressed the emergency shutdown button, when, under these conditions, a flaw in the shutdown mechanism caused a surge in power. Within seconds, fuel elements ruptured, steam pressure built up, and 2 explosions destroyed the reactor and much of the building around it. In the years after the accident at Chernobyl, reactors still operating with similar designs were made much more stable at low power. Automatic shutdown systems were upgraded to act faster and more reliably, and automatic inspection equipment was installed. Indeed, these safety changes allowed the other 3 reactor units located at Chernobyl to carry on operating, providing electricity to millions of homes until the year 2000. Every day, as part of normal life, we're all exposed to some radiation. We are surrounded by naturally occurring radiation, from the sun and cosmic rays, rocks and building materials where we live, the food we eat, as well as the human body. Radiation levels inside nuclear power plants are strictly monitored and very low, like the level of radiation found everywhere else on Earth. Exposure to slightly higher levels of radiation is a normal consequence of things we do regularly, like travelling by plane or having medical x-rays. But exposure to high levels of radiation in an uncontrolled way can cause health problems immediately and over time. The explosions at Chernobyl released radioactive material into the atmosphere. It remains the largest uncontrolled radioactive release of its kind. 2 workers were killed by the explosions. In the weeks that followed, 28 emergency responders and plant staff died because of the very high levels of radiation at Chernobyl, immediately after the accident. Over the following days, radioactive particles were carried by air to Belarus, Russia and Ukraine. Radiation from the accident was detectable across much of the Northern Hemisphere. At Chernobyl itself, hundreds of thousands of workers were involved in responding to the emergency over the next 2 years. Most received relatively low radiation doses, but the scale of the operation was unprecedented. Entire communities were also displaced. 116,000 people were evacuated in 1986, including from the nearby city of Pripyat. In the years that followed, a further 220,000 people were relocated. Alongside the physical impacts, the psychological and social effects were significant, driven by uncertainty, displacement, and fear of radiation. Because radiation isn't visible, and its effects can be hard to monitor, and at a time the authorities responsible for Chernobyl provided very little information, this accident led to the long-lasting concern about the safety of civil nuclear energy projects around the world. Understanding what happened at Chernobyl led to huge changes, not just in reactor design, but in safety culture and communication. It also changed how the global nuclear industry works together. After Chernobyl, it became clear that safety couldn't stop at national borders. This led to the creation of the World Association of Nuclear Operators, which connects nuclear operators worldwide to share experience and improve performance. Alongside this, the International Atomic Energy Agency strengthened international safety standards and global cooperation. Today, nuclear is the safest way to generate electricity at scale, and that record was forged in part by the lessons of Chernobyl. Chernobyl remains a defining moment in the history of nuclear energy, not just because of what happened, but because of what changed as a result. To learn more about what happened at Chernobyl and how nuclear safety has evolved, visit the World Nuclear Association's Information Library.